Good day, everyone. Our topic for today is all about Spearman's rank correlation coefficient, part 1. But before that, don't forget to like and subscribe to this channel and hit the bell button for more updates. Also, you will find different subjects in this YouTube channel. Just select the playlist section. Now, let's proceed to our topic for today, which is all about Spearman's rank correlation coefficient. In this portion, I'll be going to tackle on how to solve problem involving Spearman's rank. But on the second video, I'll be going to teach on how to do hypothesis testing using Spearman's rank correlation coefficient. When the entries in a set of data are ranks, the Spearman's rank correlation coefficient, also known as the Spearman rho, will be used in hypothesis testing. The formula to be used is rho, or P, equals 1 minus open and close parenthesis 6 summation of d squared over n quantity n squared minus 1, where n is the number of pairs, d the difference between two sets of ranks. The interpretation for the person R will be used in Spearman rho. When the value of R is 0.00, the interpretation is no correlation. When it is 0.01 to 0.19 or negative 0.19 to negative 0.01 is weak, very weak positive or negative correlation. The positive or negative correlation depends on the sign of your final answer for the R, and so on. So you will find here the interpretation of the R value. And if your answer is 1.00, that is a perfect correlation. If your answer is more than 1, then there might be something wrong with your answer because it is very impossible for the person R or Spearman rho to get higher than 1.00. Example: 10 instructors were rated by third and fourth year students on their mastery of the subject matter, and the results were tabulated. What is the Spearman rho value of the data? The Spearman rank correlation coefficient for the 10 instructors are the following. For the third year, let's say it is X, so we have the following scores of the 10 instructors. For the fourth year, we have the following scores. Now, in our table, we have R sub X, R sub Y, D, and D squared. R sub X and R sub Y talks about the ranks or the position of the scores from highest to lowest. The first is the highest, and the lowest will be the last rank. So for the 44, it is a rank 4, 45 rank 3, 36 rank 6, 32 rank 9, 46 rank 2, 47 is rank 1, meaning to say 47 is the highest score. 37 and 35, 27, and 5, meaning to say you need to rank all the numbers in the X. Now, for the fourth year, Y, 3.5, meaning to say there is a tie here. I think there is another 46. That is instructor number 8. Then 6, 7, 10, 8, 9, 5, 3.5, 2, and 1. 50 is the highest for the fourth year students. Now, for the letter D, we will get the difference of the ranks. So 4 minus 3.5 is 0.5. 3 minus 6 is negative 3. 6 minus 7 is negative 1. 9 minus 10, negative 1. Negative 6, negative 8, 2, 4.5, 8, and 4. For the D squared, this D will be multiplied by itself. So 0.5 times 0.5 is 0.25. Negative 3 times negative 3 is positive 9. Negative 1 times negative 1 is 1. 1, 36, 64, 4, 20.25, 64, and 16. The next thing to do is to get the summation of this squared, and that is 215.5. What is the meaning of summation of this squared? That is the total or the addition of all the d squared values. So we will add all of these and we will get 215.5. Now, we can now solve our Spearman law. N equals 10 and summation of this squared equals 215. The formula is 1 minus, open and close parenthesis, 6 summation of this squared and quantity n squared minus 1. We will just put all the two given values to the formula. So we have this one. And then, we will multiply 6 times, what's that? 215.5. And the answer is 1,293. For the other one, we have 10 squared, and that's 100 minus 1, that's equal to 99. Next, we have 10 times 99, and that's equal to 990. Divide the two, 1,293 divided by 990, that is 1.31. Subtract 1 to 1.31, and you will get negative 0.31. And the interpretation is weak negative correlation. Okay, it is negative because our answer for the raw is negative 0.31. You may go back to the interpretation in this video so that you will determine if my answer or my interpretation, which is weak negative correlation, is correct. Now, let's proceed to, I think, another example, which is number 2. Compute a Spearman's rank correlation coefficient for the variables to determine the degree of association between the two variables. So, what are these values? So, we have 11 persons given. For the x, we have 23, 41, 37, 29, 25, 17, 33, 41, 40, 28, and 19. For the y, 201, 259, 234, 240, 231, 209, 229, 246, 248, 227, and 200. Next is, we will rank the x first. So we have 23 as rank 9, rank 1.5, 4, 6, 8, 11, 5, 1.5, 3, 7, and 10. For the rank y, we have 10, 1, 5, 4, 6, 9, 7, 3, 2, 8, and 11. After that, get the difference, negative 1, 0.5, negative 1, 2, 2, 2, 2, 1.5, 1, negative 1, negative 1. And the d squared is 1, 0.25, 1, 4, 4, 4, 4, 2.25, 1, 1, and 1. And get the total. The answer is 23.5. We have now two given values. We have n equals 11 and summation of d squared is 23.5. Just put to the formula. So we have this one. And multiply 6 times 23.5 and the answer is 141. 11 squared minus 1 is 120. Next, 10 times 120 is 1,200. Divide the 2, you will get 0.12. Subtract 1 to 0.12 and you will get 0.88. Now, go back to the interpretation. What do you think is the interpretation for this raw? 0.28. The answer is very strong positive correlation. Okay, so we have another example. So you're so lucky we have 3 examples here. So Miss Rhea Macaldo and Miss Rose Hernandez rates the 8 short story made by the grade 8 students and the result was tabulated. What is the Spearman law for the data? At 1% level of significance, determine if there is a significant difference in the scores obtained by grade 8 students on their short story. Okay, for this example, in this or this particular example in number 3, I am going to leave this to you to determine what do you think is the answer and what do you think is the interpretation for this particular example. With that, thank you very much for listening and good day.